To start with, talking about Ansible Network Engine. So first of all, my name is Peter Spragata, and so far we've had some great discussion around Red Hat. We've talked about Ansible. We started to dive into Ansible Network and really what comes out of the box with Ansible in order to support network. Now we're going to start to talk about some new stuff. And really what this segment is going to be about is we're really going to start to talk now about, we've got all of this base functionality built into Ansible. What do we do with it all? Right? How does this ultimately end up helping a customer? And this is what Network Engine is all about. This is something new that we really started, I guess we started to implement this right about the turn of the year. So about January, about Q1 this past year. And it's been slow. We've been slowly ramping up to this. So a lot of what I'm going to share with you here is a lot of this is under development. It's all being done in the open source. I mean, it's not being hidden anywhere. Some of it is further along than other, but it really talks to how we're looking to take the next step with Ansible Network and really deliver on some of the challenges that organizations are facing ultimately to be able to deploy Ansible in their environment. So let's start with a very simple definition of what is Ansible Network Engine. We haven't talked a lot about Ansible Roles, but we're going to really get into Ansible Roles now. Ansible Roles are reusable units of code within Ansible. And essentially what it does is it allows us to take all of this capability in Ansible and bundle it up into kind of a single package, if you will. It's probably a terrible choice of words to say package, but nevertheless. And distribute it as an entity as opposed to having someone have to sit down and do it. So in an Ansible playbook, we have this concept of a task list. A role is nothing more than a single entry that could explode into a whole bunch of tasks. That's essentially what a role is. So Ansible Network Engine is going to be a set of consumable functions. Keyword here being functions. These are going to map to network operational use cases. And it's going to focus on automating bootstrap provisioning and configuration management. Wow. It's a wordy little sentence. But it goes back to this fundamental tenet that we're focusing on network infrastructure, and we're going to add multi-cloud network connectivity to this. All of those networking bits that are going to be required as organizations start to look at how do I start to implement my multi-cloud strategy. Oh, I still have to go build tunnels. I still have to go interconnect clouds. Yeah, all that has to happen in order to get to a multi-cloud environment. How can we help organizations simplify that? So Ansible Network Engine is being distributed as a set of Ansible roles, and we'll talk about what that means, but it's decoupled from the Ansible mainline branch. Here's one of the fundamental problems we've got from an Ansible networking perspective. Ansible is a fast-moving project. We essentially do a release every 3 to 4 months, 5 to 6, depending on how many features we're trying to get in. The problem is when you look at how much we need to do in networking, even that's way too slow, way too slow. So what we wanted to do is we wanted to build an environment where we can incubate new capabilities and start to add new feature functionality to Ansible for addressing networking use cases and on a much faster pace. So Ansible Network Engine is now going to go to a 2-week, and in fact it's there today, we do a 2-week recurring release cycle every 2 weeks. We take a very agile approach. Release early, release often. Get it out the door. Now, that might mean that a release only has one minor feature in it. But that's OK. Get it out the door. Get it in users' hands. Don't make users wait 4 months because somebody fat-fingered in source code how to send the command to shut down an interface. So these are the types of things that we start to address with Network Engine and how we can really start to incubate that and get this in users' hands and get that code into their hands in a supported way, supported being the key. On top of Engine, we have this concept now called Ansible Network Functions. Now this sounds probably fancier than it really is. It extends Network Engine, but what it does is it's just still Ansible under the covers. It basically goes off and it does something. A network function could be create VLAN. But the key to this function, to your point earlier, is that we remove all of the junk you got to deal with to say, OK, well, now I'm talking to a Juniper device, and I need to use netconf. Here's all the bunch of stuff I got to put into a playbook to abstract that or to implement that specific for the platform. And then the next host I'm talking to is a Aristabox, and now I got to go to network CLI and do all this other stuff. And I'm playing with variables and conditional logic, and now it's becoming a programming language again. If we can put all that into a role and hide that and say, really, all I want to do is create a freaking VLAN on 15 devices, That's a big win for our operations team, and that's what network functions are designed to do.
So as an aside, someone that works on systems in addition to networking,
yes,
having this available for server OSs in addition to network, those functions that overlap, is where it's more critical than just the network devices themselves.
I'm so glad you said that. So we've worked very closely with the RHEL team. RHEL is going to actually write the same, and we're going to get into what a function looks like from a block diagram and then show you one. RHEL's actually doing exactly what you just said. So that when it's create a VLAN, not only can I create on my top of rack switch, but the exact same function will then talk to my RHEL system and create it there. So absolutely. That bond versus port channel joke I made earlier, let's get rid of it. Let's just take it right off the table, right? We need to build a link aggregation between a host and a network device. Why in the world should I have to deal with putting a bunch of conditional logic in playbooks and having to understand both sides? All I want to do is create a bonded interface, or I'm sorry, a port channel interface. Forgot my crowd. Port channel interface.
So with respect to the question that was asked earlier, is this where we're starting to see the procedural and programmatic aspects come in?
Yes, absolutely it is. Absolutely.
So Ansible Network Engine is a separate productization of Ansible?
No, it's an implementation of Ansible. It's an opinionated implementation.
Right, as opposed to Ansible Engine.
Correct. So the product is still Ansible Engine. Right. This is not a product.
Okay.
This is, so if you think about Ansible Engine as this raw set of capabilities for doing automation that I can do anything with.
Yes.
Right, however I build my playbook. Ansible Engine takes it the next step and says, okay, I know that there's only a few ways for backing up configuration from a device. So I'm going to write this as a role and distribute it through our Galaxy system. And we're going to show you this here in just a moment. So that my customer doesn't have to sit down and write that, because there's no value in a customer writing that.
There's a group hallucination of standard functions.
Correct.
That everybody can reasonably reuse consistently.
Exactly.
So instead of having to keep reinventing playbooks over and over and over.
That's right.
There's a group, default functions are included in the product, and that's Ansible Engine.
That's Network Engine. That's Network Engine.
Network Engine is a curated selection of playbooks
that are
universally applicable or generally in play.
That's exactly correct. Right. Exactly correct. Because the reality is that if I'm configuring a network device, and whatever network device it is, right? If I'm configuring a device, if I'm building an interface, there's only one way to build the interface through CLI commands. What gives that interface context is the application around it, right? But the reality is whether I'm building it for a WAN environment, or I'm building it in a data center, or I'm building it, whatever my application is, the context comes from the application, not from the construct of actually building the interface. So if we can solve that problem and make it easier.
So presumably, Network Engine is then, you're effectively supporting the playbooks that come in there.
That's correct.
Selecting, curating, and then supporting those as part of the licensed or supported product.
That is correct. When you buy Ansible Engine support, when you purchase Ansible Engine support, you get support for everything you see here. And everything we're going to talk about. Now, doesn't mean you have to use it. You're welcome to use it. You're welcome to contribute to it. But you do get support for it.
And the flip side there is that at the same time, you're bringing some opinion to Ansible. Ansible has generally been a fairly large hammer.
Correct.
And it just, people go out and choose what they're going to hit with it. You're saying this hammer is now customized for this particular screw. Or nail.
That's correct.
Or whatever. Right.
That's exactly correct.
But also at the same time, you're looking for universal use cases. This is how a server's deployed. This is how you configure a VLAN on a singular Cisco device. This is how you configure a PANOS firewall rule. So why not just distribute default playbooks so that people can move on to adding value above?
Yep, that's exactly correct. The very easy analogy that I like to draw, and people tend to pick it up quickly, is what Network Engine is to Ansible Engine is the same thing as a CVD is to Cisco iOS.
Okay, gotcha.
That's the analogy.
Except CVDs are a marketing exercise.
Fair enough. Conceptually, let's say that. Conceptually, what they were intended to be, or what Cisco wants you to think that they are.
We've actually been creating our own repository of playbooks. So it sounds like you've done it for us.
Well, we haven't done it yet. We're working on it. We are working on it. There's a lot to cover here.
Okay.
But the idea being is that, because what you're doing is the same thing every customer of ours is doing, right? They start realizing, they start playing with Ansible, and they start to build some basic use cases. And before long, they realize, I just wrote the same 7 tasks 6 times.
Yeah. Imagine if I'm an engineer working for a reseller, I go around and just keep using the same playbook on every site.
Absolutely.
And do we still bill them for a full install?
You have Ansible Galaxy for that.
Well, see, now you don't even have.
Well, and that's what we're going to leverage as our distribution tool. Yeah. That's absolutely correct. Now, I'll share with you a little bit of funny story. It's funny and sad all at the same time. So we all understand, one of the dilemmas that we've had in network operations for a very long time is cut and paste problems, right? Cut from one config, paste it into a device. And I knew eventually this was going to happen, and sure enough, eventually it did. We were working with a customer in our IRC channel, and he's like, this is just not working. I don't understand. And he's giving us information back and forth. And after going back and forth for about 40 minutes, we finally got him to paste a good portion of his playbook together. And it was a copy and paste error. He copied from one playbook to another. And what he had done is he was automating, I think it was ASA and iOS or something like that. Anyway, he forgot to change the module name. So it still said, he went from like iOS to ASA, but yet the module still said iOS, and that's why it was failing. And I thought, yeah, I knew this day was going to come, right? But this is to try and help solve that particular problem.
So have you reached out to your resellers to see what they have that you might be able to utilize?
I don't know. That's a good question.
Yeah.
I don't know the answer to that.
Yeah.
Do you know the answer to that? Okay. So no, I do not know the answer to that, but that's a great question, and it's one that I should follow up on.
I imagine you're tapping into that over-enthusiastic community.
Oh, no question, no question.
So it's very opinionated, very opinionated from a very small number of people who've got lots of opinions.
But no, that's a really good point. No, we have not. I should say I don't know the answer, but it is something I would definitely like to find out, because I think it's a great point. And again, it goes back to the comment I made earlier, right? I can't tell someone how to run their network. I mean, we have a sense of what the use cases are, and we're getting them from customers, from the community, et cetera, et cetera. Some of them are easy. Getting started with this is a real easy process. I mean, we all know some of the very basic things that need to be done, right? Software upgrades, backing up configs, VLAN management, et cetera, right? These are basic things everyone needs. Beyond that, it's going to get a little bit more complex. And so I think that's a great takeaway.
And I think one of the biggest conundrums and one of the biggest problems that people think that one Ansible rules them all, right?
Yes.
But they don't understand that, when you do network automation, typically the hardest problem that you need to fix is not how you do the automation, because you have Ansible.
Yep.
Right? The problem is how you manage the data.
Absolutely.
How do you render the freaking dynamic inventory?
Yep.
And how do you manage the relationship between the data? And this is why I think that products like Apstra are clever, because that's the problem that they're trying to solve.
Yep.
So it's how you configure and how you manage the relationship between these resources.
Well, I think that talks to a bigger, well, you're absolutely right. And I think that talks to the point of, Ansible is an automation platform, right? We don't try to orchestrate. Now, that being said, a lot of folks try and put us into that orchestration bucket. And I've talked with a lot of people that'll come to me and they're like, Ansible sucks. It's terrible. I'm trying, and they start showing me the things to do. I'm like, you're doing stuff we never designed Ansible to do. It's not an orchestration system. It's not built to figure out, I want to connect a VRF on this side of the world to a VRF on this side of the world and figure out everything that needs to happen in between. That's not what Ansible does. And I think that folks who try to make Ansible do that, what they end up with 300 vars files and all sorts of associative arrays and trying to make keys map here, and it's like, that's a mess. It's a mess. And that's not what Ansible is designed to do. And that's the first thing I'll tell them. Like, stop using Ansible for that problem. Get an orchestration system if you want to orchestrate services. We will happily plug into it if you want to continue to use us. But use the right tool for the right job. It's like, we keep saying it as engineers. Right? We keep saying it, but yet it still doesn't seem to sink in.
It's like you're trying to build the machinery for like a food production line, but you're not putting the raw material, to bake the cookies.
There's a great slide that goes around internally at Red Hat. It's a public domain picture. I wish I had a copy of it right now. But it's this car that's up on two wheels and a bunch of people hanging out trying to change a flat tire of the two wheels that are in the air. And it talks about that's exactly the problem, right? Trying to change a tire on a moving car. But anyway, so let's talk about what a function really looks like. Conceptually, how we've built these functions is functions are implemented by playbooks. They provide a standard set of inputs to the playbook that you can configure, right? It's a standard set of variables, essentially. And they will produce a expected output. That's all done in what we call the function definition side of things. The Ansible function then ships with one or more providers for implementation. Now, the way that these roles are constructed, though, is that the provider doesn't have to come with the role itself. So let's put this in a real-world context. Let's say I've got a function that is, pick on something different than VLAN. I keep picking on VLAN. Create BGP neighbor. Right? So I've got a function for creating a BGP neighbor. I've exposed all of these arguments for creating a BGP neighbor. And the function role might ship with a provider for iOS, and maybe one for EOS, and maybe one for Junos, and maybe one for NXOS, and et cetera, et cetera. And along comes vendor XYZ. Acme Packets. I can go that far back. Do they even still exist anymore? No, I think they got bought, didn't they?
How about Oracle?
That's right, yeah.
I remember those things.
Yep. So anyway, new networking vendor comes along and they want to be part of this role. Or a customer says, I want you to be part of this role. I want you to integrate with this role. They can actually write their own provider. You can drop it inline in the playbook. The role will figure it out. It'll find it, pick it up, and immediately start using it. So the customer doesn't have to wait for someone to write a new module. It doesn't have to wait for a new release of Ansible. They simply get the provider either from their vendor or from their own dev team, and they're off and running. In addition to that, if there's a problem in this provider, they can actually create a copy of it outside the playbook. We actually prefer that one, so that if there's a bug in there, we have no bugs in our code, but if someone else wrote the code. So if there's a bug in it, we can just create a copy of it on the outside. It'll pick that one up. It'll find that one first. And it's all in the construct of the role. We're actually going to go look at here one in just a moment. But I want to get through the stack first, just so you can kind of see how these all pieces go together. And then we'll stop. I'll stop yakking so much. We'll actually look at some things and try and tie all these concepts together. So we started the day, we talked about Ansible Engine. And this is where we're at today, right? Everyone knows this. This is basically Ansible. Ansible comes with a set of connection plugins and a set of network modules. Now, the connection plugins today are CLI, API, NetConf. We're working on a new API plugin over HTTP called HTTP API. Real ingenious name. I think I was part of coming up with that one. We're working on RESTconf and GNMI are all on our roadmap right now, and things that we're going to work on. Now, someone in the community wants to contribute one sooner, we're happy to accept it, but it's definitely on our roadmap right now to work on. We also have a bunch of unopinionated network modules. And if anyone's ever used Ansible, they know what these modules are. iOS config, iOS command, NXOS fax, et cetera, et cetera. These modules in the network space are fairly dumb, to be quite honest with you. They're really designed to simply send a command and get some output. That's all they're designed to do. There's no context. There's no understanding. It expects something else to tell them how and why and what they should be doing. But that's what comes out of core. Now, we are going to start looking at Ansible Core as an upstream project. I'm going to explain what I mean by that here in just a couple moments. But the Ansible team continues to maintain everything that's there, work with the community, and make that happen. On top of that this is where Network Engine comes into play. So Network Engine is a role. And what you find in Network Engine is a bunch of configuration and operational delivered plugins for Ansible. These are components that are not ubiquitous enough to really belong in the core Ansible distribution, but are horizontal enough in the networking world that it doesn't make sense for every vendor to implement them. So let me give you a good example of something that shows up in Network Engine. We've got a new filter plugin there for expanding VLANs. Right? We all know if you look at a show running config, you get VLANs 1 through 10. Well, when you need to deal with that at a programming standpoint, that's a pain in the butt. So we have a new filter that will explode that out into a list. 1, 2, 3, 4, 5, da, 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 da. That's an example of something that shows up in Network Engine and that we can make use of. And how we make use of that is, finally, these higher order functions. We classify the higher order functions into device, application, and cloud. And we're going to spend some more time talking about why those 3 buckets exist and what that really means.
So I have another question from Twitter.
Great.
It's actually more of a statement. This is from Dimitri in Warsaw, Poland. It becomes a pseudo-programming language, yet limited by the declarative nature of the playbook, lacking strong debugging tools present in modern programming languages. Complex playbooks and custom modules are not human readable and can't be supported by usual network operators.
I fully agree with that statement. So that's exactly why we're building this architecture. So what you're going to see when I go into the demo side of this thing here in just a moment, I keep saying we're going to get there. We are going to get there. What you're going to see, though, is that we're trying to move as far away from the code as we can. We're trying to get to a place where we only go to code when we absolutely have to solve a problem. And that's what you're going to see in this set of network functions. So how this actually looks, though, is if you think about Ansible from a stack perspective, starting at Ansible Engine, that's mostly developer-focused, all the way up at the top for functions, which are going to be more operator-focused. But the salient point here is the fact that I can interface at any one of these levels. I can build playbooks that include functions. I can build playbooks that include straight to Network Engine. I can build playbooks that encompass direct to Ansible Engine. So what that means is that let's assume I'm a smaller shop. I don't really care how I define my network. All I know is I got to push config onto it. I don't care how it's defined. I don't care about data models. I don't care about any of that stuff, right? I just want to make it very easy to make a configuration change. They're probably sitting right up here somewhere.
If it's a small shop, do you even need this?
It's a good point. It's a good point. Maybe, maybe not. All depends. It also depends on what your idea of small is. Everything's subjective in this world.
Yep.
If you had 100 devices that you were just managing independently, and you're doing fairly basic stuff, I don't think so.
No.
Yeah.
But if you were starting to get into cascading, like Dvorkin said it well. He said, "What's the difference between a plane crash and a car crash?" When a car crashes, most people don't die most of the time. When a plane crashes, you usually die. So it comes down to what your blast radius look like.
Yep.
This is an attempt to mitigate the blast radius of a failure. How much does it take down? Right? So if you're flying a plane, you need this type of redundancy and testing and validation and scale and breaking it down. So you don't have a plane crash because you don't want the plane to ever crash.
Right.
But of course, you've now got all the overhead. You've got, aircraft have massive systems to support it to make sure it doesn't crash.
Yeah.
But we do very little about car crashes because when people have a car crash, we don't care. Because they don't normally die. Occasionally they do.
So
That was the strangest analogy I've ever heard.
well, here, let me give you another interesting thought about smaller networks. So let's say, fine, we got a 10-node network, right? Do you really need automation? Probably not.
No.
Say a 100-node network, do you need it? Probably not.
Maybe.
Probably not. Maybe. But remember, automation doesn't have to necessarily be just about configuration. You can also automate troubleshooting.
True.
And there's where there's an interesting use case for, say, a 100-node network.
Goodbye, stare and compare.
Absolutely. Absolutely. We've got many customers that have learned the fine art of, we have an exception event on our network. Part of doing the root cause analysis and remediation is to write a playbook to diagnose that problem anytime in the future. So they never have to do it again.
Like configuration post checks to make sure.
Absolutely.
Or just to follow the agile practices.
Absolutely.
That's our friend Greg loves very much.
So automation doesn't always have to be just about pushing config onto devices.
Yeah, and also my experience is that people tend to start with a small network and say, well, I don't know automation, but the network all of a sudden becomes 100 nodes. And they had, oh crap! If I started with Ansible from the onset, I would be on my boat in the Bahamas now.
Yep.
The other side of 100 network devices, if you're in a data center, that's something like 10,000 servers. So you may not want Ansible to scale this for the networking, but you definitely do for 10,000 servers.
Yep.
Oh, yeah.
And you might as well handle 100 networking devices.
That's right.
Right. So it's a case of Ansible wants to take over the entire world. Right. Run your controllers, run your file, and bring it all together. So yeah.
And to me, it's also not so much about the number of nodes, but the churn of change. Because if you have 10 nodes and you have 20 changes per hour, well, probably it's not too good, right? But
yep, all absolutely true points. So we can interface at the function layer. We can also interface at the network engine layer. And this is going to be mostly for those organizations that say, we want to be very opinionated about how we do things. So we've got the formula figured out. We show you how to build these functions. And you can take that and you can start to build your own on top of Network Engine and implement them in your own environment. And then last but not least is some organizations want to interface right at the Ansible engine layer. I'll give you a perfect, for instance, on this particular one. We've got one customer right now that wants to automate their wireless base stations in their mobile network. Now, there makes no sense for Ansible engineering to ever write that code because it has such a small use case in the grand scheme of the world, right? A lot of nodes, but only a few companies that actually need that code. What we did is we actually showed them how to write a connection plugin. They actually wrote a connection plugin to talk to their wireless base station, and are starting to automate and looking at automating their wireless infrastructure.
You talking about like LTE, or are you talking about fixed mobile broadband?
LTE in this case.
Okay.
Yep.
So that's interesting that you say that's a limited use case, because that's one of the most ubiquitous pieces of network infrastructure that will exist on the planet.
I agree, but in the grand scheme of Ansible, it's not.
Not for your scope.
Correct.
Okay.
Correct.
Gotcha.
That's right. That's right. Not to mention, in that particular case, there's no way we could have written that because, again, I'm not going to be able to convince anyone right ahead to let me go off and buy a LTE infrastructure so I can write code against it.
Just because I'm morbidly curious, is it the eNode B that you're trying to automate specifically?
In this particular case, yes.
Okay.
It is. It is. And then last but not least, Ansible Tower comes over the top and provides all of this great functionality that we're going to start looking at. So, putting it all together, we've got a function, kind of lines with the concept of engineering. Go off and do something. Then we got operations that provides specifics for the implementation, and the output from that ends up being production-grade infrastructure. Okay, we're going to start getting into some demos here. But I did want to touch on, I talked about the fact that we've got these three buckets in the functional world. We look at the world in kind of these three big buckets, and we actually have teams that are focused in each one of these. And I'm going to show you demos in two of the buckets. The middle one I won't, but I'll at least walk you through what the generalized use cases. First one is device-centric automation. Everyone knows this one. This one is today. This is what we do today. I want to go out and I want to push config to a network device. Pretty straightforward. Or I want to pull information from that network device. The second kind of generic use case is this idea of application-centric network automation. This one's kind of a fun one. This one really talks more to the orchestration side of things, right? Ansible is the automator. We're not the orchestration system. I can't tell you the best way to connect two devices together. I can't tell you if your ECMP paths are actually going to work in an outage situation. I can't tell you if your A/B failover actually is going to be properly reflected in the network when it happens, right? Orchestration systems can do that. And we're going to talk about some of the things that we're doing there. And then last is cloud-centric. And I keep kind of harping on this multi-cloud environment. And how do we build, right, the cloud infrastructure and ultimately connect it all together? OK. Device-centric automation. Really, the salient point here is that we want to support in any model, any encoding, any transport concept. What we mean by that is that we should not have to saddle the implementer with having to make decisions up front. One of my favorite things to sit back and watch with a big bucket of popcorn is the open config debate. and whether you're for open config or against open config, the reality is that that isn't something that should be driving network operational decisions. I should not have to make a decision about how I run my network based on open config. That should just be another tool.
Damn it, networking is all about yak shape.
Does anyone?
If we didn't take the care and attention to detail that a command line gives us, we'd all be like, you know, at nuclear war by now.
I'm curious. Does anyone remember? I do. You might remember. I don't know. Back in, I guess it was early 2000, there was an effort underway in the IETF to create an industry standard CLI. Did anyone know that?
That would be cool.
There's an ISO standard that defines.
Yep.
Cisco, I think from memory, the Cisco iOS interface.
Yep.
Actually derives from an ISO standard that was set way
back.
Before Cisco even existed.
Yep.
Yeah.
But the effort in the IETF started because this is about time Juniper was really, now they were really becoming a force in the space, and folks were frustrated because it was killing their OpEx, right? Having to support Juno CLI and iOS CLI. And then there was all of the MPLS God boxes. I actually worked for one of those startups, disclaimer. I was at Vivace. But they all had their own interpretation of a CLI. And of course, then you had all the ATM switches and the frame relay switch. Anyway, but yeah, there was an effort in the IETF. It didn't get very far. And I kind of laughed to watch us repeat these mistakes over and over and over again. I'm not saying OpenConfig is inherently bad. My point being is that, again, it's right tool for the right job. That's what it all comes down to every single day. What we're trying to do from an Ansible perspective is make that easy. Take that decision off the table for organizations.